All right, before the break, we were talking about abstract classes, looked at aggregation and composition earlier. And without thinking about it, I'm just in the habit of taking a break shortly after 7 and completely forgot that tonight was intended to be a very short night. So there's only about 20 minutes of material left after the break. So a short section here to kind of continue. Probably should have took a break about 20 minutes earlier or something to split it nicely in half, but sorry about that. I'm just in the habit of looking at that clock and waiting for the hand to pass 7, the minute hand to get past 7 and a nice stopping, nice pause point. So that's one way we can sort of make a rule for things to follow, what we were looking at beforehand. We made an abstract method because we didn't have the details to put that in there till later. And whenever there's abstract methods, we have to say it's an abstract class. We can't quite instantiate it. Probably should have made an example earlier. Made a copy of that. I'm going to make a new project. Java example, I'll call this object example 3. I probably should have made a copy of the earlier one. Actually, I can get a copy of the earlier one, can I? Clear out all these comments in this main one. So all the stuff that did not change, cat and covering and dog. Oh, well, I guess not really. Those 3 I can copy straight over, or I can go to GitHub and just grab the example from last week. Probably should have made a copy before changing that example. Always a good idea, right? Make a copy and then make changes. Why is that in way up? We go object example 1. I go to the source code here. I think it'd be quicker just to grab all of this, grab all that code and just paste it in someplace new. Or that's what I often do. There's a handful of them, so maybe I'll just download this. Because I have to go all the way up here, download it. Oh, download. I just need regular. I can copy the old code from that one and have it just like it was for tonight's example. So after class, I'm going to change that one we did earlier to object example 4, so it doesn't write. So when I upload it on GitHub, look for object example 4 to see the abstract one. Probably should have made a copy ahead of time. And remember, it's always a good idea to make copies. Work with a copy, that way you don't mess up the original. Or at least keep in mind that of how to get back to the original in case you ever need to. Object example 1 in the source file. I'll just grab all of these. Oops. I'll grab all of them there. Yeah, I'll go ahead and grab all of them. Grab all these, which drag and drop works. Let me get that out of the way. So here's the new package here. So if I come over to File Explorer and with all those selected, I can just drag them over there. It is a File Explorer. It interacts with your other File Explorers, so all the drag and drop and normal copy and paste stuff works. So then what's in this one, everything here is copied over to the new one. There's the new main class. It'll ask about imports and all that. Close that. Save that one, and there should be error messages showing up. There they are. Okay, notice it's the wrong package now. When you drag and drop that way, it, if I would have done hit copy and then paste over here, we looked at that earlier, it pops up a little box about correcting that package name. But the drag and drop didn't actually read through the files to notice the package name was wrong, like the copy and paste. So you do have to click this button and either move it to the correct folder or change package name. We want it in this new folder, so change the package name, and that's probably the same in every single one. Change package declaration. Change package declaration. I think this is going to keep going there, showing errors when I get all these changed. So that way it works, but it does leave this little issue here. But you can see it's not, the IDE can automatically correct it. So like, okay, this is the only problem. So what do we have to do to fix that? Oh, wait, that one can be deleted. Delete that one. This one. Why is it still showing an error? Oh, the compiler had it running. Now the error should be fixed, right? Oh. That auto import was wrong because now all of these are threes. I always try to point that out in class. Let me redo that. For those who haven't had me in class before, I don't think this has shown up. You'll see lines of code like this a lot, right? But this one you've all probably seen that where every line is very similar. Something that's not exactly intuitive to a lot of people starting out is it's more productive to work down your columns than across. If we work across, in this case, there's only one change. We have to start here at the beginning, look at what's going on. Oh, there's what needs changed. Keep looking at it. And if there's 3 or 4 changes on that line, you have to change your frame of mind 3 or 4 times. It's like, okay, this is where I changed the data type. This is where I changed the reference value. This is where I changed the argument passing into the method. And you might have to change your mindset 3 or 4 times on those lines that look very similar. And then do the same thing on the next line. Go to the next line and start over. Change your mindset 3 or 4 times. And on the next one, change your mindset 3 or 4 times. But if you work downward, you don't have to change your mindset as much, or you only have to do those changes 1 time. So you set your mind for like, maybe it's the data type. What needs changed with the data type, and then work down all those columns. Then you change your mindset once and get that next change. Like these all need to be 3s. And then you just go down that column, and then you're not changing your frame of mind as much. The way you're approaching the code, what you're thinking about. That thing that's hard to put into English. But you're not constantly changing your mind in order to make those corrections. You change it once, make all those changes, then change it once and change everything that applies. So it's actually more productive to go ahead and copy and paste those lines and work downward instead of left to right. We're not working in English. Left to right, top to bottom is not as important as it is in the English language. This isn't even what the computer runs, right? This gets turned into something in machine language. And, this is very, very different than what runs in machine language. So little things like that can make a big difference when we're writing code. Go ahead and do copy and paste or duplicate the line, and then make all the work downward to make the changes. Or if there's a bunch, work down and back up and down. And then your cursor is kind of in the same spot. There's different little tricks. Like if you copy and paste something that's going to have a bunch of quotation marks, and then it's going into a string, so you have to add escape sequences. It's much better to just start at the end of the line. Think about it ahead of time, because then if you start at the end of the line, the color changing will work correctly as you move backwards. And you'll be able to tell when you're at the beginning, because everything will have changed to the correct color. So just thinking about the way that you do those things can make a difference. Okay, so now we should be back to where it was before the break. Okay, yeah, there's where we had the other day. In the same situation, with our animal object, the parent, this method's not so good. We don't really have we don't have a good thing to use for make sound. We need that default value is not going to work well, so I'm going to take that off. And at this point, the only error messages we're getting are where we see that make sound method. Okay, instantiating animal object somewhere, yeah. Creating a new animal from a constructor is fine. It's not abstract, it's concrete, we just don't have that method. I'm going to change those as well. Where's the other stuff? Oh, I guess the other one didn't have quite as good of a, I guess the other one didn't get back, the most recent one didn't make it back to GitHub. I thought it did, but apparently not. Looks like I went 2 versions back on GitHub. Let me copy and paste from the one we just did and kind of make the changes there. So from there to there, delete all those, yes. And on the one we just did, oops, copy that. And then what I like to do is highlight the folder and then hit Control V to paste it. So now we get all this thing about copying, and notice the checkbox is to not refactor it. We definitely want to refactor it. That'll make all the corrections and stuff. So if we do copy and paste, we actually can refactor it. There we go. So now it'll run without issue. We can close a bunch of these. But I don't want to make an abstract class. We might need to make an animal at some point. So instead of putting an abstract method, which essentially just gave us a rule the child classes have to follow, we can manually make that rule for the child classes to follow. Or yeah, if we look at one of these now, it doesn't override anything. There's nothing saying that we have to we had to create and make sound method. That's where an interface comes in. Oh, I guess I should copy this as well. Copy that. Paste that in there and then change the 1s to 3s. 3, 3. Oh, is it still in there? Oh yeah. 3, 3. But we have this problem down here in that method we wanted to make. We need to interact to access that animal class of that. But maybe when we make this method, we have no idea all the details that are going to be worked in to use it, like all the child classes and things like that are going to be used. So we need to set up some rules that allow us to interact with this. Or our technical term for that is going to be to interface with this. Interface means interact with. We have a keyboard interface and a screen interface on our computers, a mouse interface. Interface means machines are set up to interact with each other. these plugs, if they're showing up on the camera. From the KV switches here in the lab, which isn't quite long enough. Oh, whoops, down, not up. You can see those plugs. You can see that on the camera. There's two USB plugs, an HDMI, and some OPS1 plugs for the KVM switch. So that you can, if you stop by the computer lab here, you can use your own laptop with the monitors instead of the desktop that's here. So a lot of people prefer to use their own laptop, right? Those are interfaces. It's hardware interfaces, but they're standard. This will fit in any USB port. Sorry, not any USB type A port. That will fit. We're all standardized. That's what it means to interface things together. And we have a similar thing in software. We need to interface software together, which is the very problem where the error message we're getting here. Well, it writes it out kind of fancy, like cannot find symbol. It looks like you can't find it, but we know it's there. The problem is we're not set up to interface these two pieces of software together. So to do that, we use interface like a noun and actually create something called an interface. So it goes right in the package. I'll click on the package name, a new one. So halfway down the list, you'll see Java interface. This is the adjustable list, so it's in order of what I've clicked on recently. The general default list is going to have interface right near the top. We look at Java interfaces above enum. It's sort of the second most important type of data type we can put together. For somewhere we'll create a new interface. I'll call this noisy. And that's setting up some rules that our animal objects have to follow. In order to be an animal object like we designed here, it has to be noisy. And an interface is solely a list of abstract metadata. No code in an interface, only the metadata. So you'll have the public void my method, public string, private string different method, and you'll have all those method headers, but you'll never have that curly braces in the block. Just the list of the methods that need. So noisy, in order to be an animal, it has to agree to follow this rule. It's going to have a public string method called make noise. We can also put in some constants. I can't think of any for this example. Can't think of any for animals. A common one is like tax for payroll calculators, the tax forms. There's different tax brackets, right? We don't have the 14% tax and then every possible value going up to an 18% tax, right? You're either in that 14% tax bracket or you're in the 18% tax bracket. So we only need a short list of constants. So instead of making an enum, we can put constants here. Kind of using the math class ones. The ones that do not change can go in an interface because they're not going to change, they'll be the same everywhere. So use the math class terms, not the programming terms for constant and variable. Constants and method headers can go in there. So that gives us a rule that we can implement and say, okay, things have to be noisy to be an animal. Sort of a criteria for it. And our keyword for that is implements. IMPLE. So animal implements the noisy interface. And if we click here, again, we see that same code generation we saw earlier for that error message. Implement all abstract methods. So now animal has that method we can use, which I'm going to leave off here because I believe it's set up in a way that we can, because the one this was copied from was abstract. So now we can create animal, but animals don't make noise. But any child classes of animals, things we want to use here, we need to make sure those follow that rule and implement that interface. So on all these other ones like cat, extends animal. So extends a parent and implements an interface, noisy in this case. And notice now the only thing that's underlined is that override method. Or sorry, the actual override keyword in the annotation. So we don't need annotations from the interface. Yes, it does. Oh, sorry, that was supposed to be make sound. That was just a silly typo on my part. Hopefully some of y'all probably noticed that. Like, why did you put make noise? Isn't our method make sound? That's what I meant to put there. So then we override that. And it's a lot more common to leave that off with an interface. Let's see, what else needs it? Dog. It extends animal and implements noisy, which fixes that error message. Same thing on eel. They all have that. So implements noisy, which basically saying this subclass of animal is going to follow the rules that are set forth for the method that it needs to be using. Make sure we can use it. There's a way we can check that we will see later. It would be a bit much for today. So for now, just think of it as like an agreement to follow those rules. Extends animal and implements noisy. And we can implement more than one class. We actually did the other day, didn't we? If I go back to this example in vehicle, we implemented more than one interface. So we can, if we want multiple methods to keep track of, we can only inherit from one parent, but we can implement lots of interfaces. For our class example, there's only one, so I want to make sure I point that out somewhere. I should close some of this. Implements noisy. Close that. Lions are also noisy things, so implements noisy. They make a lot of noise. Now, object example 3. We're still seeing a bit of a problem here, right? It's saying it doesn't know what that is. That's because animal doesn't have that interface, doesn't really have that particular that interface in it. I did that on purpose. I left it off animal and put it all in all the subclasses, because this is that example. If you, since there was a little back and forth there with the copy and paste, this was the example. I did end up copying the one we did before the break. It's the same. So we're never actually implementing an animal. Everybody see what I did there? See some slow head nods here in their classroom. Sometimes it's better just to write the code and see what happens. An interface is a data type. So instead of going to that animal that's the parent of everything, I can use that interface. So this method is going to work with anything that uses that interface. As long as it followed the rules to be considered noisy, it'll work in this method. And that gives us ways to check and stuff too. We can use casting and try catch blocks and things to confirm that it's there, but that's basically the idea. An interface is a special type of class that is basically only abstract. There's no way we could implement things here, but it is still a data type. And we view it as a list of rules. Our rule in this case is that something that's noisy has to have the make sound method, which could apply for more than animals, right? We could put make sound over on our vehicles. We could copy this over to that other package and say that those different vehicles are noisy. Some of them are going to have a very different make sounds, right? For a sedan, we want a really, really good muffler on that because a sedan or a minivan, you're probably driving your kids around. You want to hear what your kids are doing in the back seat. In case there's a need to turn around and yell at them. So you need to hear that over the muffler. But in a souped up Firebird, you probably don't want the quiet muffler on there. You want people to hear that coming, right? Same thing on a motorcycle. We never put mufflers on motorcycles. People want to hear those the impressive engines when we can. Or sometimes in minivans, people just don't have a few bucks to fix them. So that set of rules could apply elsewhere. There's more than one place we can use that. So instead of an abstract class where we're only stuck with those child classes, we can make them an interface that we can use in lots of situations.
So is noisy a parameter in that?
Noisy is a type. So animal is the parameter. So we'll fill animal, and then we'll use the animal class dot make sound. But the type of that parameter, it has to be noisy type of data. And noisy refers to that interface. So anything that's noisy follows those rules. Does that answer your question?
Sure. Does it matter what order you put those in?
Yes. Because it's our Java syntax. We always do
So you have to
type.
type for the parameter.
Type and then reference. Okay. Yes. So parameter is the reference about the reference name we want to use here. And then we'll send an argument to fill that parameter. But that's the reference. That's what we use over and over and over in our code. And by Java syntax, the type goes first. We're going to start getting the error message. Oh, comment out those. Okay. That was an error message from a different example. We're looking at interfaces tonight. The downside to reusing the examples, but hopefully it all kind of makes sense there. Does anybody have any questions about interfaces or abstract classes? You know, there's two ways to kind of reach that same goal. We couldn't make that method, but we knew we were going to use that method, so we had to require it somewhere along the way. Abstract classes we can only use that method in the child class, and with an interface, we can use that method. We could use it more generally, but it still basically applies the same way. We implement the interface as sort of a green to create any methods listed in it, which is what we did with that other one, like the comparable interface. It has compare to. Or I always like to write this one on the board. When we did that vehicle class, we also implemented serializable, which we have to do that in order to serialize our data, which is so we can write it to a file. We can't write it as a file or a stream unless it's serialized. And that one in particular, it looks like this. We write all the code for that on the board. Because we didn't have to implement any methods with serializable, right? And we saw that because the interface, public interface, serializable. Might have spelled that wrong. Then opening curly brace, closing curly brace. I'll just do that. That's all the code in there. There's no methods wrote there, but there's other ways we can use it. They basically did it in that type thing. But like Bradley was asking about the type and the parameter. When we go to write a file, it will try to cast our data into serializable. And if it can't, then it won't let us write it to a file. But there's no actual rules to follow. It's just something on the background will try to cast it into this type before moving further, working with it any further. Just to make sure it's set up. So we can also, there's different ways we can use them. What we're going to want to do in this class is basically what we did here. Think about it like a set of rules we have to follow, and then implement that in our classes, or create an abstract class, or for practice, maybe do both, which is what you'll actually see. I believe everybody is required to take the mobile app development class, right? SDEV 264. I see it was one head taking note. For those who have to take the mobile app development class, if you're doing the Android one, for every class that you have for the Android stuff, there's also an interface, so that it is basically up to your personal style. There's a 1-to-1 ratio, and you can choose whether you use the classes and instantiate an object and work with it, or use the interface and just add those methods to your own object. So that is very, very common in libraries. You'll see both interfaces and abstract classes that mix together for the personal preference of which one you prefer. But the basic idea is what we saw there. Kind of get started with them. It's another one that's kind of hard to see the usefulness of. It's like, why don't we just write that? But it does pay off in the long run. As projects get bigger and bigger and bigger, it becomes more and more useful. With teams, also, it becomes very, very useful because everybody's writing different code. So you want to make sure everybody's writing code that interfaces together and works together. So that's probably the easiest place to visualize where the usefulness of it. We have an assignment on interfaces and abstract classes that I think is it's the shape assignment. So for an abstract class, we have some abstract shape. It's going to have a few things about it, but there's certain things that we know are going to be there that we can't do in the parent class. In particular, I'll just jump down to the methods section. We're going to have a get area method, right? Anytime we're doing working with geometry, just traditional mathematical geometry, we know all of our shapes are going to have an area. But if it's just a shape, we have no idea how to calculate that area. When we get some subclasses of that, like the first three things I thought of were all three-dimensional. I started to write frustrum and pyramids, but those don't have areas, those have volumes. A similar thing, triangle. That's the two-dimensional versions of those things. When we make a triangle subclass of shape, it's going to inherit a lot of things. Side length, base and height. Maybe we have those in there. Because also with base and height, we could do the trapezoid. And in those shapes, we know how to find the area. Or at least we know how to look up the formula for the area and punch that into some, with Java syntax. But there's a formula for those, but for a generic shape that includes everything, it's kind of hard to say what the formula is. But we would know other things. We did base and height. That's what we use for triangles and trapezoids. But that would work for parallelograms. Oh, actually, that's what we use for parallelograms as well, isn't it? But it's going to work for rectangles. Basically, everything but a circle would work for that. If we had a circle, we could just make one of them pi. Say base is pi and height is whatever radius we have. And then it would still work for that. It's just our labels would be a little bit off, right? But the parent class is abstract because we know some things about it, but we can't fill in one of our most important aspects. We know a shape has an area, but we can't say what that area is until we know what shape it has. I think that's the one on your homework assignment. And the formula should be written out to work with. But you'll use abstract classes and then a similar thing with interfaces. We'll make a simple interface. If time allows, I know time's a precious commodity. If time allows, I would recommend doing what we did tonight. And instead of like, this might be the assignment for abstract class, go ahead and do abstract class and interface. It'll be worth bonus. I'll put bonus points on it. A whole bunch of bonus points, especially what each assignment's worth. But like I think there's 3 chapters this week. So whatever the point value is, divide that by 3. And if you do that twice, you'll get that extra third of bonus, just extra credit for the extra work. But it will, that is something that will definitely pay off. Do that same thing with abstract classes and with interfaces. And on your interface one, do it the same way. The assignment for doing interfaces, do the interface like the assignment says, and then for extra credit, go ahead and do the abstract classes versions that would get you the same result. Because ultimately that we do that a lot when we make libraries, packages for other people to use. We do like Google did with the Android libraries. We provide both the abstract class and the interface, so that way whichever style a particular programmer has, they can just use the one that fits their style. And they, the end result is the same. One of them we make new objects, and the other one we add methods to our object. But ultimately very similar. Does anybody have any questions about abstract classes and interfaces? At least day 1 questions. That's the main topic for this week. So we're going to talk for this module. So we're going to talk about it a couple times, add more details, but hopefully that helped with a good introduction. And then those things from the beginning of the night tonight, aggregation and composition, keep those words in mind. Loose relationships, one of them being much more important than the other. Because you will see those over and over and over again on exams and quizzes and exams on your way through school, and then certification quizzes and exams. And that is a very, very common question to ask software developers in interviews to make sure they know the difference between aggregation and composition. Otherwise, that was it for this evening. I meant to finish up about 10 minutes ago. That leaves it, well, we still got about an hour of class left. As always, if you have any questions, I'll be sitting here waiting to answer questions, text messages, and everywhere messages from noise on my phone. I'll be sitting here unless everybody leaves. I'm the last person on campus. I'll probably head back to Clarksville. It'll take me about 10 minutes to get home. So there'll be a 10-minute gap before I can jump back on a Zoom call. Otherwise, I'll be sitting here ready to jump back on a Zoom call and address questions in a split-second notice. Does anybody have any questions before we head off our separate ways to do some work? Okay, I assume a few seconds of silence there means no questions. Please use our time productively. Your calendar should have our time slot blocked off to saying learn IT. So make sure you're learning IT stuff. I know this isn't everybody's only class, so you probably have homework in other classes, and I do teach more than just this class, so feel free to send me other questions as well. I'm always happy to help. Otherwise, I will see you all on Thursday. Everybody have a good night.